Overall, it sounds like the electrical installation for the pool wet niche and light has been completed correctly. Some comments and recommendations are as follows. Concerning bonding, all metal parts of the pool, including the niche, ladder, pump, heater, and coping, have been bonded using number 6 copper wire, which is essential for safety. The niche installation mentions that the copper lug in the niche that connects to the number 6 copper wire should be securely fastened to the niche. The copper strip that connects the lug to the screw receiver should also be securely attached. For the light installation, the sealed light should fit snugly into the niche and be securely attached with the screw. This will ensure proper electrical connection and prevent water intrusion. The polyvinyl chloride conduit that runs from the niche to the junction box should be properly sealed and supported to prevent water intrusion and damage to the wires. For wiring, the white, green, and black wires from the light cord have been correctly connected to the white, green, and black wires from the power supply. The use of 12 American wire gauge stranded wire is appropriate for this application. The use of a ground fault interrupter is required for pool electrical installations. It helps protect against electrical shocks. Additional recommendations include: for any major electrical work, it is always recommended to consult with a qualified electrician who can ensure that the installation meets all applicable codes and safety standards. Once the electrical installation is complete, it is important to test the system to ensure that it is functioning properly. This includes testing the light, the ground fault interrupter, and the bonding system. It is also important to follow all instructions provided by the manufacturer of the niche, light, and any other electrical components used in the installation. Electrical safety around swimming pools is of utmost importance due to the combined presence of water and electricity. The National Electrical Code, or NEC, provides specific regulations and guidelines to minimize the risk of electrical shock and prevent potential hazards. Some of the key aspects of electrical safety for swimming pools as outlined by the NEC are bonding and grounding. Bonding involves connecting all metallic parts of the pool structure and equipment to create an electrically continuous system. This includes the pool reinforcing steel, metal fittings, pump motor housings, and any other metallic components within a specified distance of the pool. The purpose of bonding is to equalize the electrical potential between these parts, reducing the risk of shock if a fault occurs. Grounding, on the other hand, involves connecting the bonding system to the earth through a grounding electrode. This provides a path for fault current to flow back to the source, tripping the circuit breaker or ground fault circuit interrupter, or GFCI, into energizing the circuit. Ground fault circuit interrupters, or GFCIs, are crucial safety devices that detect even small amounts of current leakage to ground. When a ground fault is detected, the GFCI quickly interrupts the circuit, preventing electric shock. The NEC requires GFCIs for all electrical outlets, circuits, and equipment located within a certain distance of the pool. This includes outlets for pool pumps, lighting, and other electrical devices. The NEC specifies minimum distances for the placement of electrical equipment and wiring around swimming pools. These clearances are designed to prevent accidental contact with electrical sources while in or around a pool. Overhead power lines must also maintain a safe vertical clearance above the pool area. Underwater lighting is another important consideration for pool electrical safety. The NEC requires that underwater luminaires be specifically listed and labeled for pool use. These lights must be installed with proper grounding and bonding connections to minimize the risk of shock. Low voltage lighting systems, typically operating at 12 volts, are often used for underwater lighting to further enhance safety. Regular inspections and maintenance of pool electrical systems are essential to ensure continued safety. Electrical connections should be checked for corrosion or damage, and any faulty equipment should be repaired or replaced promptly. Ground fault circuit interrupters should be tested regularly to verify their proper operation. It is highly recommended to consult with a qualified electrician for any electrical work related to swimming pools. A licensed electrician has the knowledge and expertise to ensure that the installation meets all applicable codes and safety standards. They can also perform inspections and maintenance to identify and address any potential hazards. Some important definitions to keep in mind include bonding, which refers to the permanent joining of metallic parts to form an electrically conductive path that ensures electrical continuity and the capacity to conduct safely any current likely to be imposed. Grounding refers to a conducting connection, whether intentional or accidental, between an electrical circuit or equipment and the earth, or to some conducting body that serves in place of the earth. A ground fault circuit interrupter, or GFCI, is a device intended to protect personnel by de-energizing a circuit when a ground fault exceeds some predetermined value that is less than the required to operate the overcurrent protective device of the supply circuit. An equipment grounding conductor refers to the conductive path installed to connect normally non-current carrying metal parts of equipment to the system grounding conductor or the grounding electrode conductor, or both, which accomplishes one or more of the following: limiting the voltage to ground on these parts, facilitating the operation of overcurrent protective devices, and carrying ground fault current safely. A grounding electrode conductor refers to the conductor used to connect the system grounding conductor or the equipment to a grounding electrode or to a point in the grounding electrode system. Some of the National Electrical Code references include 680.26, which covers bonding requirements for swimming pools, 680.21, which covers underwater lighting, and 680.22, which covers GFCI protection. Number 6 copper wire is often used for bonding pool equipment and metallic component. This size is typically specified to ensure adequate conductivity for carrying fault current and equalizing electrical potential. The actual size required may vary depending on the specific installation and local codes, so it's always best to consult the NEC and local regulations for the most accurate requirements. When running a bonding wire around a pool, it should be connected to all metallic parts of the pool structure, including the reinforcing steel, metal fittings, and any other metallic components within a specified distance of the pool. The bonding wire should also be connected to the pool equipment, such as the pump motor housing, filter, and heater. The connections should be made using listed bonding connectors and should be accessible for inspection and maintenance. The purpose of bonding is to create an electrically continuous system that minimizes the risk of shock if a fault occurs. By connecting all metallic parts together, the electrical potential is equalized, reducing the voltage difference between these parts. This helps to prevent current from flowing through a person's body if they come into contact with a faulty piece of equipment. Ground fault circuit interrupters, or GFCIs, are required for pool electrical installations to provide additional protection against electric shock. GFCIs are designed to detect even small amounts of current leakage to ground and quickly interrupt the circuit, preventing a potentially dangerous situation. The NEC requires GFCIs for all electrical outlets, circuits, and equipment located within a certain distance of the pool. This includes outlets for pool pumps, lighting, and other electrical devices. GFCIs should be tested regularly to ensure they are functioning properly. A typical test involves pressing the test button on the GFCI, which should cause it to trip and interrupt the circuit. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. When wiring a pool pump, it's important to follow the manufacturer's instructions and all applicable electrical codes. The pump should be connected to a dedicated circuit with the appropriate overcurrent protection. The wiring should be sized correctly for the pump's current draw, and the connection should be made in a weatherproof junction box. The pump should also be properly grounded to prevent electrical shock. If the pool pump is located more than a certain distance from the electrical panel, a subpanel may be required to provide a convenient and safe connection point. Subpanels should be installed according to the NEC and local codes, and they should be properly grounded and bonded. When installing underwater lighting, it's important to use luminaires that are specifically listed and labeled for pool use. These lights are designed to be waterproof and submersible, and they are tested to ensure they meet safety standards. Underwater lights should be installed with proper grounding and bonding connections to minimize the risk of shock. Low-voltage lighting systems, typically operating at 12 volts, are often used for underwater lighting to further enhance safety. These systems use a transformer to step down the voltage from the main power supply, reducing the potential for electric shock. The transformer should be located in a dry, accessible location and should be protected from the elements. Regular inspections and maintenance of pool electrical systems are essential to ensure continued safety. Electrical connections should be checked for corrosion or damage, and any faulty equipment should be repaired or replaced promptly. Ground fault circuit interrupters should be tested regularly to verify their proper operation. The pool water should also be tested regularly to ensure it is properly balanced. Improper water chemistry can damage pool equipment and increase the risk of electrical shock. It is highly recommended to consult with a qualified electrician for any electrical work related to swimming pools. A licensed electrician has the knowledge and expertise to ensure that the installation meets all applicable codes and safety standards. They can also perform inspections and maintenance to identify and address any potential hazards. Some common mistakes to avoid when working with pool electrical systems include neglecting to bond all metallic parts of the pool structure and equipment, failing to install ground fault circuit interrupters where required, using undersized wiring or improper connections, not following the manufacturer's instructions for equipment installation, and neglecting to perform regular inspections and maintenance. Avoiding these mistakes can help to ensure a safe and enjoyable swimming pool experience. Pool electrical systems should be inspected annually by a qualified electrician to ensure they are in good working order. The inspection should include a visual examination of all electrical components, testing of ground fault circuit interrupters, and verification of bonding and grounding connections. Any deficiencies should be corrected promptly to prevent potential hazards. When replacing pool equipment, such as pumps or heaters, it's important to ensure that the new equipment is compatible with the existing electrical system. The new equipment should be installed according to the manufacturer's instructions and all applicable electrical codes. The electrical connections should be made by a qualified electrician to ensure they are safe and reliable. Pool electrical safety is an ongoing process that requires vigilance and attention to detail. By following the guidelines outlined in the National Electrical Code and consulting with qualified professionals, pool owners can minimize the risk of electrical shock and ensure a safe and enjoyable swimming pool environment. When selecting electrical equipment for a pool, such as pumps, filters, and heaters, it's important to choose products that are specifically designed for pool use. These products are typically constructed with corrosion-resistant materials and are tested to meet stringent safety standards. Look for products that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or ALL, or Electrical Testing Laboratories, or ETL. These listings indicate that the product has been tested and certified to meet applicable safety standards. When installing electrical equipment near a pool, it's important to consider the location and orientation of the equipment. Equipment should be located in a dry, well-ventilated area and should be protected from the elements. It should also be positioned so that it is easily accessible for maintenance and repairs. The equipment should be installed according to the manufacturer's instructions and all applicable electrical codes. When running electrical wiring near a pool, it's important to use the correct type of wiring and to install it in a safe and secure manner. The wiring should be sized correctly for the load it will be carrying, and it should be protected from physical damage. The wiring should be installed in conduit or other approved raceway, and it should be properly supported and secured. The wiring should also be installed at the correct depth below ground level, as specified by the National Electrical Code, or NEC. When making electrical connections near a pool, it's important to use the correct type of connectors and to make sure the connections are tight and secure. The connectors should be listed and labeled for the application, and they should be installed according to the manufacturer's instructions. The connections should be made in a weatherproof junction box to protect them from moisture and corrosion. When working with electrical equipment near a pool, it's important to take precautions to prevent electric shock. Always turn off the power to the equipment before working on it, and use insulated tools and equipment. Wear rubber gloves and shoes to provide additional protection. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working with electrical equipment, hire a qualified electrician to do the work. The National Electrical Code, or NEC, provides specific requirements for swimming pool electrical installations. These requirements are designed to minimize the risk of electric shock and to ensure the safety of pool users. The NEC covers a wide range of topics, including bonding and grounding, ground fault circuit interrupters, or GFCIs, underwater lighting, and wiring methods. It's important to be familiar with the NEC requirements for swimming pool electrical installations before starting any electrical work. Local electrical codes may also have additional requirements for swimming pool electrical installations. These codes may be more stringent than the NEC requirements, and they may vary from one jurisdiction to another. It's important to check with your local building department to determine the specific electrical code requirements for your area. A qualified electrician can help you to understand and comply with the NEC and local electrical codes. They can also provide guidance on the proper installation and maintenance of swimming pool electrical systems. Hiring a qualified electrician is the best way to ensure that your swimming pool electrical system is safe and reliable. When hiring an electrician to work on your swimming pool electrical system, it's important to choose someone who is licensed and experienced in pool electrical work. Ask the electrician for references and check their credentials. Make sure the electrician is familiar with the NEC and local electrical codes. Get a written estimate from the electrician before starting any work. The estimate should include a detailed description of the work to be performed, the materials to be used, and the total cost of the project. Don't be afraid to ask questions and to clarify any concerns you may have. A good electrician will be happy to answer your questions and to explain the work they will be performing. The grounding electrode conductor should be sized according to NEC Table 250.66, based on the size of the service entrance conductors. The grounding electrode conductor should be connected to a grounding electrode system that meets the requirements of NEC sections 250.50 through 250.60. A common grounding electrode system for swimming pools includes a ground rod, a ground plate, and the metal frame of the building. The grounding electrode system should be installed in accordance with the NEC and local electrical codes. The equipment grounding conductor should be sized according to NEC Table 250.122, based on the rating of the overcurrent protected device in the circuit. The equipment grounding conductor should be connected to all non-current carrying metal parts of the electrical equipment, such as the motor housing, the metal conduit, and the junction boxes. The equipment grounding conductor should be installed in accordance with the NEC and local electrical codes. The bonding conductor should be sized according to NEC section 680.26, which requires a minimum size of number 8 American wire gauge copper wire. The bonding conductor should be connected to all metal parts of the pool structure, including the reinforcing steel, the metal fittings, and the metal equipment. The bonding conductor should be installed in accordance with the NEC and local electrical codes. The ground fault circuit interrupter, or GFCI, should be installed in a readily accessible location, such as a weatherproof enclosure near the pool equipment. The GFCI should be tested monthly to ensure that it is functioning properly. To test the GFCI, press the test button on the GFCI. The GFCI should trip and interrupt the circuit. If the GFCI does not trip, it should be replaced immediately. The GFCI should be replaced if it fails to trip when tested, if it is damaged, or if it is more than 5 years old. Underwater lighting should be installed in accordance with NEC section 680.23. The underwater lighting should be listed and labeled for swimming pool use. The underwater lighting should be installed at a depth of at least 18 inches below the water surface. The underwater lighting should be supplied by a low voltage transformer that meets the requirements of NEC section 680.23. The low voltage transformer should be located in a dry location and should be protected from the weather. Wiring methods for swimming pools should comply with NEC Article 680. Wiring should be installed in rigid metal conduit, intermediate metal conduit, or rigid polyvinyl chloride conduit. Wiring should be buried at least 18 inches below grade. Wiring should be protected from physical damage. The NEC specifies that all metal parts within 5 feet horizontally from the inside walls of the pool and extending 12 feet above the maximum water level must be bonded together. This includes metal fences, metal posts, and metal parts of pool equipment. The bonding connections must be made with listed bonding connectors and must be accessible for inspection and maintenance. The NEC also specifies that all electrical equipment associated with the pool, such as pumps, filters, and heaters, must be grounded. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electric shock. The grounding conductor must be sized according to the NEC and must be connected to a grounding electrode system that meets the requirements of the NEC. In addition to bonding and grounding, the NEC also requires the use of ground fault circuit interrupters, or GFCIs, for all electrical outlets and circuits within a certain distance of the pool. GFCIs are designed to detect even small amounts of current leakage to ground and to quickly interrupt the circuit, preventing electric shock. The NEC requires GFCIs for all outlets within 20 feet of the inside walls of the pool, as well as for all circuits that supply power to pool equipment. The NEC also has specific requirements for underwater lighting. Underwater lights must be listed and labeled for swimming pool use and must be installed in accordance with the NEC. The NEC requires that underwater lights be installed with a ground fault circuit interrupter, or GFCI, and that they be bonded to the pool's bonding system. The NEC also specifies the maximum voltage for underwater lights, which is typically 12 volts. The NEC also has requirements for the location of electrical equipment around the pool. The NEC specifies minimum distances for the placement of electrical equipment from the inside walls of the pool. These distances are designed to prevent accidental contact with electrical equipment while in or around the pool. The NEC also specifies that electrical equipment must be located in a dry location and must be protected from the weather. The NEC is a complex document, and it is important to consult with a qualified electrician to ensure that your pool electrical system complies with all applicable requirements. A qualified electrician can help you to design and install a safe and reliable pool electrical system. They can also perform inspections and maintenance to identify and address any potential hazards. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. The latest version of the NEC is available from the National Fire Protection Association, or NFPA. In addition to the NEC, there may also be local electrical codes that apply to swimming pool electrical installations. These codes may be more stringent than the NEC requirements, and they may vary from one jurisdiction to another. It is important to check with your local building department to determine the specific electrical code requirements for your area. A qualified electrician can help you to understand and comply with the NEC and local electrical codes. They can also provide guidance on the proper installation and maintenance of swimming pool electrical systems. It is important to remember that electricity and water can be a dangerous combination. By following the guidelines outlined in the NEC and consulting with qualified professionals, pool owners can minimize the risk of electrical shock and ensure a safe and enjoyable swimming pool environment. When dealing with electrical installations near a pool, ensure all metal parts are properly bonded using a number 8 American wire gauge copper conductor or larger. Connect this conductor to the pool's reinforcing steel and any metal components like ladders or handrails. Ground fault circuit interrupters, or GFCIs, are vital for any electrical outlets within 20 feet of the pool's edge. These devices quickly cut power upon detecting even minor ground faults, significantly reducing the risk of electric shock. Underwater lighting must be specifically designed and listed for pool use. These lights operate at low voltage, typically 12 volts, and require proper grounding and bonding. Always follow the manufacturer's instructions for installation and maintenance. Maintain safe distances between electrical equipment and the pool. National Electrical Code, or NEC, guidelines specify minimum clearances to prevent accidental contact with electrical sources. Overhead power lines should be at least 22.5 feet above the pool's water level. Regularly inspect all electrical components for damage or corrosion. Replace any worn or faulty parts immediately. Test ground fault circuit interrupters, or GFCIs, monthly to ensure they're functioning correctly. If a ground fault circuit interrupter, or GFCI, fails a test, replace it immediately. Keep electrical equipment dry and protected from the elements. Use weatherproof enclosures and fittings to prevent moisture from entering electrical components. Avoid using extension cords near the pool. If necessary, use a heavy-duty extension cord with a ground fault circuit interrupter, or GFCI. Never swim during thunderstorms or when lightning is present. Electrical currents can travel through water, posing a severe risk of electric shock. Post clear warning signs around the pool area, reminding users of electrical safety precautions. If unsure about any aspect of pool electrical safety, consult a qualified electrician. They can assess the installation and provide expert advice. Remember, safety should always be the top priority when dealing with electricity near water.